Hi third year, this is a quick lesson looking at formula equations. This is new learning, but there is just one slide that is important that everybody writes down into their jotter, and then the rest of the lesson is worked examples. So you should take down 2 or 3 worked examples, paying attention to all of them and making sure that you pause the video at any point if you need a wee bit more time. So, formula equations then. A formula equation represents a reaction. This is the slide that you need to write down, okay? In a formula equation, the names of the elements or compounds are replaced with formula. So for example, magnesium reacts with oxygen to form magnesium oxide. So that's just a statement, that's just a piece of text. We can change that into a word equation by placing plus signs between the names of elements and compounds and arrows that indicate the reactants on the left and the product on the right. So this stage we should all be happy with doing so far. Today we're going to add in the next step, which is substituting the formula for the name. So instead of writing magnesium, we just put in the symbol for magnesium, Mg. Instead of writing oxygen, we put in the symbol for oxygen, O2, the formula O2. And then for magnesium oxide, which is a compound, we would need to work out the formula using our formula rules, which comes as MgO. So that's what a formula equation is. It's just the same as a word equation, except we substitute in the formula for the different elements and compounds. Okay, so we're going to try 3 examples where we're taking the formula equation from a word equation. So here we've got sodium plus chlorine, arrow sodium chloride. So sodium is a metal, it's in group 1, that's fine. And then chlorine is a gas that's in group 7. Now it's a diatomic gas, so that's going to affect what its formula is. And then sodium chloride is a compound. There's nothing complicated about this formula. We don't have any Roman numerals or prefixes or anything, so we can just calculate that formula using our SVSDF rules. So this one is going to be sodium is Na plus Cl2 arrow, and then let's work out sodium chloride with SVSDF. So sodium and chlorine, well, sodium's in group 1, chlorine is in group 1, so actually now we can skip down to the bottom and just write NaCl. So that's the formula for sodium chloride. And that's our formula equation complete there. Let's look at example 2. So we've got hydrogen plus nitrogen monoxide gives water and nitrogen. Okay, so in this example then, we've got hydrogen as an element, but it's diatomic. We need to remember that. Nitrogen monoxide. So because we've got a prefix here, we actually don't need to use SVSDF to work out the formula for this compound. We've got water. Now, water is actually not the chemical name. The chemical name would be dihydrogen oxide. But everybody is kind of familiar with the formula for water to be H2O. So often it's just written as water and that's assumed. Nitrogen is another element, but like hydrogen, it's diatomic. So let's substitute those formula in now. Hydrogen is H2 plus nitrogen monoxide, so nitrogen with 1 oxygen, changes to water, so the formula for water is H2O, and nitrogen, which is N2, because we've remembered that it is diatomic. Example 3 from a word equation. Now, one of the other things that we learned in Unit 2 that we didn't learn in Unit 1 was about the formula for some organic compounds. So by organic, what we mean is carbon-based compounds. So we learned about methane, ethane, propane, and butane, and so on. We learned the alkanes, we learned the alkenes, and we also learned the alcohols. If you were given the name of one of those, you would be expected to know the formula for it. So for propane, I know prop is the prefix for 3 for an alkane. And because it's ane, then it's got a general formula, CnH2n plus 2. So if there's 3 carbons, then there's going to be 8 hydrogens. It's reacting with oxygen, a diatomic element, carbon dioxide, where the clue is given for the formula because we've got a prefix there, and water. So let's substitute in the formula. So propane is C3H8, Oxygen is O2, carbon dioxide is CO2, and water is H2O. Right, so if we have a word equation, then it's simple to substitute in the correct formula to give us a formula equation. But sometimes in an example, we're given it in text, okay? So by that I mean we've got a statement or a series of statements that indicate the progress of a reaction, but they don't display it as a word equation. So when we're given a piece of text like this, the first thing we want to do is identify the reactants and products. So here I'm going to put the reactants in yellow and the products in green, okay? Right, so when fluorine gas is put in contact with calcium metal at high temperatures, calcium fluoride powder is created in an exothermic reaction. Okay, so I've identified that fluorine gas and calcium metal are the reactants and calcium fluoride is the product by reading the text. So we're going to write down our word equation. Now, we don't need to put the words like gas or metal or anything like that into our word equation. Only the names of elements and compounds, i.e. only things that we can write formula for. So fluorine, our word equation then, fluorine plus calcium becomes calcium fluoride. And now we need to substitute in the formula. So fluorine is diatomic, so we'll write F2. Calcium just a group 2 element, so it's just Ca. And then calcium fluoride, we need to use SVSDF. So we've got Ca and F. The valency of calcium is 2 and fluorine is 1. We can swap them, can't divide them anymore. So it's going to be CaF2. So the product formula will be CaF2. Okay, so same thing for this one. We've got, okay, so this text actually starts off with the product because it says zinc phosphide can be created. So actually zinc phosphide is the product here. So I'm going to use the green highlighter to show zinc phosphide. So that can be created when zinc sulfide reacts with aluminium phosphide. And then we're told here aluminium sulfide is also produced. So that is a second product. So I'm going to have to write a word equation where I've got zinc sulfide and aluminium phosphate as the reactants, and then zinc phosphide and aluminium sulfide as the products. Let's get going with writing our word equation then. So zinc 2-phosphide plus, sorry, started at the wrong end there. So zinc 2-sulfide plus aluminium phosphide becomes zinc 2-phosphide and aluminium sulfide. Okay, so let's write in our formula underneath here. So what we'll notice is because the zinc is a transition metal, we're given the valency 2 in Roman numerals here. So we'll still need to use SVSDF, but the V will be 2 from the name rather than looking up in the data book. So let's just work out SVSDF for the zinc sulfide. So that's going to be Zn and then S. So Zn is 2 and S is 2. Right, okay, so we don't need to swap them, but we do need to divide them down. It's a 1-to-1 ratio, so the formula is actually going to be ZnS. Okay, so we'll put in the formula underneath ZnS. And then now let's move on to aluminium phosphide. So SVSDF, aluminium and phosphorus. So valency for aluminium that's in group 3 is 3, and phosphorus that is in group 5 is also 3. So again, no need to swap, but we divide them down to 1 and we actually get ALP as the formula. Okay, so we've got our second formula, ALP. Now let's move to the zinc phosphate. So SVSDF, the zinc and the phosphorus. Zinc has a valency of 2 and the phosphorus 3, so we swap them. Can't divide them any further, so the formula will be Zn3P2. So we'll pop that in Zn3P2. And then we've got aluminium sulfide. So we've got SVSDF. The symbol for aluminium is Al and for sulfur is S. The valency for aluminium is 3 and for sulfur is 2. So we cross those over, can't divide them any further, and it's going to be Al2S3. Let's make sure that we've got plus signs and arrows in the correct places. So that would be the finished formula equation for this example. Okay, here's another one with an interesting part in it, because this one is telling us that ammonia, and we're given the formula in brackets because we would not be expected at this stage to memorize the formula for ammonia, burns in air to form nitrogen dioxide and water. Okay, so before I actually highlight the reactants and products, we need to be clear that the thing that it's burning in within the air is the oxygen. Okay, the ammonia is only reacting with the oxygen from the air, but since we haven't actually separated out the oxygen from the other components of air, like nitrogen, then we can't say that ammonia just burns in pure oxygen. It's burning in the air, but it's reacting with the oxygen from the air. So let's highlight our reactants and products. So ammonia and oxygen are the reactants, and then nitrogen dioxide and water are the products. So ammonia, we've got the formula. Oxygen is a diatomic element. Nitrogen dioxide has a prefix, so we'll need to work that out. And then water is H2O, as we know. So let's write our word equation. So ammonia plus oxygen, arrow, nitrogen dioxide, and water. And then we substitute in the relevant formula. So ammonia is NH3, oxygen is O2, and then nitrogen dioxide is NO2 because this di part means 2, and water, which is H2O. Okay, next example then. So we've got diphosphorus pentoxide. So we've actually got two prefixes in this one, di and penta. And it says diphosphorus pentoxide is a white powder which can be made. So this is going to be our product from its elements. Right, so it doesn't actually tell us what the elements are, but we can work it out because diphosphorus pentoxide must have phosphorus and oxygen. So the word equation for this is actually going to be phosphorus plus oxygen becomes diphosphorus pentoxide. And then this is just an element, this is a diatomic element, and then this is one where we need to use the prefixes. So let's substitute in the correct formula. Phosphorus is P, oxygen is O2, and diphosphorus pentoxide, P2O5. Okay, our final example then. So in this example, we've got a new chemical called potassium chlorate, and we've been given the formula. Again, if you're ever given the formula, that just means that you wouldn't be expected to work it out from the name. So potassium chlorate decomposes. Decomposes means breaks up, okay, when heated. So potassium chlorate then must be our reactant, and it forms solid potassium chloride as well as oxygen gas. So our word equation would then be potassium chlorate, arrow, potassium chloride, and oxygen. Okay, so substituting in the correct formula. So for the potassium chlorate, we're given in the question KClO3. For the potassium chloride, we need to use SVSDF. So potassium and chlorine, 1 and 1. We can skip down to the formula and it's just KCl. So KCl for the formula there. And then oxygen is the diatomic element, so it's O2. Okay, so hopefully you feel a bit more confident now, both in writing the formula and in substituting the correct formula into a word equation to make a formula equation.